So basically in this part, as in the physics, we have seen the like how we are going to continue the physics portion. We have seen which books we have to follow and what are the things we have to follow. Similarly in chemistry also, I will like to tell you that how you are going to, or how we are going to basically cover the syllabus and how we are going to follow the things. So basically in chemistry, if you try to understand the type of question, you will understand that the major portion is NCRT. Okay, major portion is basically NCRT. So our main preference will be given to the NCRT. We will try to give more priority to NCRT. Okay, so this should be given as more priority. That is our first priority. What you have to do, see, I will provide you proper notes, proper NCRT concepts, NCRT notes with concept. Okay, and whatever you read on that day na, try to read the NCRT on the same day. Which topic you covered, which topic I covered that day, try to just go through the NCRT once for that particular topic. Okay, regularly go through the NCRT. That is your regular work. Go through the NCRT. And if you ask what you have to solve, what to solve, the preference should be, first preference should be PYQ, previous year question. Second is NCRT. And third, if you like, you can solve NCRT example or any reference book, whatever you like. Okay, any reference book. I am not recommending anything, but there is a one book which is very famous. You can use Pardeep for chemistry. Okay, you can use Pardeep. That is a very good book on chemistry, so you can follow that. Other than this, you can get the online also. This book you can get online also if you want. And see, our in chemistry we have basically three parts. Okay, the first we have a physical chemistry. Second we have a inorganic, and the last is organic. See, if I categorize in the term of which is easier, which is difficult, so see, this part is very easy because mostly the formulas are there. This is very easy portion which we are going to cover because the most of the part will be going to be the formulas only and small easy concepts. A lot of concepts will be very easy. Inorganic, this is going to be a little difficult for everyone. Why? Because you have to mug up lot of things. You have to mug up completely. Okay, but I will tell you the tricks and I will tell you the way to remember the things. We will understand the way to remember, like how to remember the things, because there are a lot of reactions are there. Okay, and organic, that is most difficult portion, most difficult. Okay, so this is how the chemistry, we will first start with the physical part. We will try to cover the physical, then we will move to the organic. In last we will cover the inorganic. This is the way of covering the chemistry syllabus in any institute you can go. But we will go in this way, and we will first try to finish the physical part. We will first start with solid state, then we will move to the state of matter and the solution and all those chapters, and then we will come to the organic portion. We will cover from start from the 11th, because organic only when you understand, when you start from the 11th, then only you can understand the organic, otherwise you won't. So we will first start with the 11th, we will cover all the portion of 11th, and then we will move to the 12th. Okay, so I hope everything is clear regarding like how we are going to proceed. And as you know about the classes, we will have a evening session for the chemistry. Okay, so there should be no doubt regarding the class. Evening session, 5:30 p.m. to 7 p.m. we will having a chemistry session, and in this we will cover the chemistry portion, and morning session is for physics. Okay, so in today's class we are going to start a chapter that is called as a solid state. Okay, our portion will be going to be solid state, that is going to be start. This is our first chapter we are going to start. Okay, so just if anyone want to note down anything, just note it down, and if you are ready we will going to start. So any doubt is there till here, you can let me know. Anyone have any doubt regarding anything? Any doubt is there? If anyone have doubt, please let me know. Okay, when I ask you something, please answer as soon as possible, because I don't want to waste my time and you also don't want to waste your time. Okay, so let us start. So we will first try to understand what are the different state of matters we will have. Generally, if we see, we have a five state of matter, but we are not going into the five state. If we talk about generally, how many state of matters we have? Can anyone tell me how many state of matters we have? Just unmute your mic and tell me how many state of matters we have. Unmute your mic. Don't type in the comment section. Just tell me how many state of matters we have. Please tell me how many state of matters we have.
The three.
Three state of matter. What are the names?
Solid, liquid, gas.
Solid, liquid, gas. Are you present in the morning session?
Yes.
Okay. So yeah, we have a three state of matters. That is, first one is solid. Second one is liquid. Whatever the question I will ask, no need to write it in the comment section. Just unmute your mic and let me know. And gas. Okay. Now the thing is that how this solid, liquid, and gas are classified. Like on what basis we have did this classification? What is the basis of doing this classification? Like on what ground? If you have classified this into a different state, so on what ground you have classified it? Can you tell me the ground? Like on what basis you have classified it? Can anyone let me know what is the basis of the classification? On what basis? Anyone let me know what are the on what basis we have classified the different state of matters? Anyone let me know what on what basis you have classified the different state of matters?
For atomic structure.
Atomic structure. Like, can you be little specific? Like exactly what you're talking about? Okay, atomic structure is somewhat okay, but what can you be more little specific regarding this? See, there are the two important. Just note. Just try to make the note along with me. Okay, because for chemistry it is very important. You should have a very proper notes. If you have a good notes, then means your rank will be easily improved. So first thing is which is very important. That is first on what first basis is the force. Okay, intermolecular force. That is first base is interforce. You can say force. What type of force? This is a intermolecular force. If you remember in class 10th, we learn about this, right? That is force. Second criteria is the distance. Intermolecular distance is the distance. Distance, what type of distance? That is intermolecular distance. Intermolecular distance. So in solid, this force is very strong, right? This force will be in solid. This force is strong, right? If the force is strong, that means the particle will be very close to each other. So the distance will be what? Very small, right? Similarly for liquid, this force will be, let us come to the gas first. In gas, the force of intermolecular force is very weak, right? So here the force will be very weak. And if the force is weak, then the particles will be very far apart. So the distance is very long, or you can say large, whatever you can say. But in liquid, this force is intermediate between these solid and liquid. So it is intermediate. And also this distance will be also intermediate. Right? So this is the different types of classification of matter on the basis of the intermolecular force and the distance we have classified like this. Okay, just note it down. And if anyone have a doubt, I don't think so you have a doubt regarding this, but this is a classification. We should know that how the matters are. See, there are the two further states are also there, plasma, another state, but it is not important for exam point of view. Just you have to remember this, these three states are there as a, these three states are present, and we have to study in this chapter. We have to focus on the solid state. This is our major point of consideration. Okay, here now let us talk about the properties of solid. Like, what are the important properties of solid? As we have seen, there are like different state of matters are there, but what are the important properties of the solid? Let us talk about that. So let's give another heading, that is properties of a, or you can say characteristics of solid. See, this is a little theory portion. In first class there will be some little theories there, and like lot of questions, theory questions also come from this portion. So you have to not skip this part, you have to prepare this part also. So like first important thing is about this is like what should be the first characteristic of a solid state? Can anyone tell me what is the first characteristic of solid? What is the first characteristic of solid? Any one characteristic, can you let me know what is the one characteristic of a solid?
Sir, occupy space.
Sorry?
Occupy space.
Occupy space, or you can say, better say, it occupies some volume, it has some definite volume. Okay, so in better language you can say it has a definite volume, right? And if something has a volume, that means it will have a, it will have what? If something has a volume, it will also have a mass, it will also have a shape. So you can say a solid, or any solid will, first thing is that it will have a, it will have a definite shape, mass, and volume, right? Second property, can anyone tell me second property of a solid? Second property of a solid, second property, can anyone let me know? See, fast, you have to tell fast. This is a very basic thing I am asking you. It's a thing of class 11th. I guess class 11th not, it's a thing of class 10th. You know, like, what is the second property of a solid? You don't see solid, everything is solid, this pen is solid. What is the property of a solid? What is the second property of a solid? What is the second property? You don't guys don't know the any property of a solid. What is the second property of a solid?
The electrons are so close to each other.
See, there are the two properties are written here. They have a strong intermolecular force. They have a small intermolecular distance. This is a simple. This is the property only, na, right? So you can say it has a strong intermolecular force. See, everything no need to mug up. You have to use your brain. Okay. Then there is nothing. You will understand that lot of things is easier to learn. Okay. It has a strong. Sorry, small intermolecular distance. Any other property? Any other property? Think fast. Any other property? Try to think. You have a solid. Everywhere solid is present, right? Try to think. You have a solid in front of you. Just try to think. What is the another property?
Sir, cannot be compressed.
Yes, that is a one of the property, or you can say in another word, how you can say that it has a its particles. In other manner, you can say it particles has a fixed position, or you can say fixed shape. Shape we have used here, so we can say it has a fixed position. Whatever the particle or whatever the shape, everything is fixed for it. So that is the another property we can mention, that the particles, okay, the particles have a fixed position, right? Because if the particles don't have a fixed position, it can be compressed, whatever you have mentioned. So but it has a fixed if it don't have a fixed position, it will be easily compressed, right? But it has a fixed position, that's why it is not possible to compress it. So the particles have a fixed position, right? Second property. That is a fourth property. Now one more property. Can anyone let me know another property? Another property? Any one more property? Think what is another property it can be? Any one property? They are they are rigid and incompressible. Okay. So these are the different properties of a, or you can say characteristic of a solid. Any doubt till here? Anyone have a doubt?
No, sir.
Okay, just note it down. I will move it to the next page. Note it down fast. If you complete it, please let me know. Completed?
Yes, sir.
Okay. Everyone completed?
Yes, sir.
Okay. So now next is types of solid. Because this chapter revolve around solid, so we should now leave everything and we have to study about the solid only. So first is types of solid. How many types of solids are there? Anyone remember how many types of solids we have? Does anyone remember how many types of solid we have? Can anyone tell me how many types of solids we have? You don't remember anything? How many types of solid we have? Hmm? I have drawn a line now. You can now guess also how many types of solid we have. How many types of
Two.
solid? Yes, two types. So what are the names? Can you tell me the name? One is
Crystalline solid, amorphous
amorphous solid, right? Very good. If my spelling is wrong, please correct it, okay? And please forgive me for this.
Solid.
Okay, okay. Amorphous, solid, right? These are the two types of solids we have. Which is called as a true solid? Which is called as a true solid? Or a real solid? Which is called as a true solid?
Crystalline solid, sir.
Crystalline solid.
Yeah, crystalline solids are called as a true solid, right? So first, let us write the properties, okay, for this, because 1 mark question can be asked from here. So first thing, crystalline solids are the true solid. They are the real solid. So if they are the real solid, the first thing they will have a regular shape, okay? Because suppose this is a pen, this is a real solid, right? So it has a regular shape. So it will have a regular shape, right? First property is that it has a regular shape, right? Second thing is that it has a sharp melting and boiling point. It will have a sharp means like it will melt at a particular temperature, like ice is melt at what temperature? 0 degrees Celsius, right? At 0 degrees Celsius the ice start melting, okay? So that is a sharp temperature. So that is what, suppose I take a iron at 5000 degrees Celsius, the iron start melting. So that is a sharp value. It is not like that it should be in the range. No, it is a sharp value. So that is the first, second property. It has a sharp melting and boiling point. It, sorry, sharp melting point. Third property. Third property. Now you can guess what is another property it can be. Can you guess?
Sir, anisotropic in nature.
Sorry.
Anisotropic.
Anisotropic in nature. What do you mean by anisotropic in nature? Anisotropic in nature. Just give some space here, okay? Anisotropic in nature. I will tell you what is the meaning of this. If anyone know, please let me know. Otherwise, I will explain. Third property, it has a sharp latent heat of fusion. What do you mean by latent heat of fusion? Latent heat of fusion means converting solid into the liquid. Okay, if I want to convert any solid into the liquid, the amount of heat I have to give is called as a latent heat of fusion. And it has a very high, or you can say sharp latent heat of fusion. Obviously, that is obviously a true thing, because it's a true solid. So it will have a definite, or you can say high latent heat of fusion. So it has a definite latent heat of fusion. Next thing, next property. Next property, that is long range order. Long range order. Long range order means, like if there is a solid is there now, the particles arrangement will be same all over the like surface. Suppose I want to see the particle arrangement for this. So what is the particle arrangement for this portion? The same type of particle arrangement will be present at this here, this. So that means if I know the particle arrangement at here, I can predict the particle arrangement of the other portion also. So that is called as a long range order. Okay. Six point is that it is true solid, that we have seen also. It is a true solid. It is named as a true solid. Clear? Now my question is, what is anisotropic in nature? Can anyone let me know what is anisotropic in nature? What is the meaning of anisotropic? What is the meaning of anisotropic? What is the meaning of anisotropic? Please fast. What is the meaning of anisotropic? Till you are thinking, I'm writing the amorphous properties. What is the meaning of anisotropic?
The property, sir, it is the property of by which the Structures differ when measured in different directions.
Like what properties? Which type of properties? Which type of property?
Structural property, sir. Structural property.
Structural property, or we can say it as a physical property. Can we say as a physical property?
Okay, sir.
Yeah, like I'm asking you, can we mention it as a physical property? Is it true? Is I'm saying right or wrong?
We can, sir.
See, the thing is that anisotropic means like the property is whatever the physical property or structural property come under this. Okay, this is a structural property. Means how the structural arrangement is there. So structural arrangement in every direction is same because I mentioned it is a long range order. So you cannot mention it as a structural property. It is a physical property. The physical property is different in different direction. That is called as an anisotropic in nature. Okay, so if I'm writing anisotropic means that they have a different physical property. Is it visible now? Properties in different direction. I don't know why it's changed color. Different direction, right? This is the meaning of anisotropic in nature. Now, yeah. So we are writing this. Yeah. So it has a diffuse melting point. Oh, sorry, numbering is wrong. Yeah, it has a diffuse melting point. 1, 2, 3. This is isotropic in nature. Now can you tell me what do you mean by isotropic in nature? Can anyone now tell me what do you mean? What is the meaning of isotropic in nature?
Physical properties in same direction.
Physical properties are same in not in the same direction, in all direction. You can say in every direction you will go, all the every direction you measure the physical property, they are same. Like what is the meaning of this? Like in different direction you will get a different physical property, but here in every direction, in every place you will get the same physical property, right? So we can write like this. We can say that same physical property in different direction, or same if you are using like different direction, you can say different direction. Like in any direction you go, you will get the same physical property. Like for example, I take this, suppose this is a solid. Okay, this is a crystalline solid. I have measured that some one of the physical property here. Okay, and then I'm measuring the one of the physical property here. So here, what, suppose I am getting some value x, the here I will get some another value y. That is the thing. But if I take a amorphous solid, like suppose it is a amorphous solid, now if I measure the one of the physical property here and suppose its value is x at this point, I can measure any other point. Okay, let us suppose here only, I will get the same value x only. That is a problem that you mean by the isotropic in nature. So same physical property in different direction. Here different physical property in different direction means different direction you get different physical property. Here same physical property you will get in any direction or any different direction. That is the meaning of this. Okay, now the next thing is that what I'm saying, sorry, it has a, oh sorry, it has diffused latent heat of fusion, and second thing, short range order, and last is it is also called as a super colded liquid. Super colded liquid. Do you know why it is called as a super colded liquid? If you have seen the old buildings, just go to any old building which is like more than 100 years old. Okay, and just go and see their glasses. Okay, you will see that The glasses are thin at the upper end and it is thicker at the bottom. The glasses are thicker at the bottom. Why? Because it is an amorphous solid. Amorphous solid has basically a liquid property. So during those number of years, it will flow like a liquid. So all the liquid come to the down. So that's why it become thicker at the bottom and thinner at the upper side. So that is why it is called as an amorphous solid. So glass is one of the example of amorphous solid, like, right? So any doubt till here? Any doubt is there?
No, sir.
Okay, just note it down. See, if you have anywhere doubt, please ask me. Okay, if I will ask and you will say no, sir, I am not able to understand, then it will be difficult. Let us write down some example. Can I change the slide?
Yes, sir.
Okay, sir.
Everyone is making the notes with me or not?
Yes,
Is
sir.
Yes, sir.
everyone is making the notes? See, it is very important for in chemistry. See, if you will make a proper notes, your life will be very happy. I am giving you a guarantee. You have to make a proper notes. Otherwise, your life will be very bad in chemistry. Okay. So let us see some examples. First, we will see the example of crystalline solid. Examples of crystalline solid. So let us see some examples. Okay. So first example, we can see like there are the different types are there. We will see later. We will see this later. Let us mention it is a benzoic acid. Benzoic acid. Okay. Second, you can take KNO3. Third, for example, you can take silicon. And fourth one will be like copper. And another one is SiO2 quartz. See, whatever the example I am writing, this I am writing from NCRT. So you have to remember this example very properly. I am teaching line by line NCRT. You can go and just read the book. You will find that this is each every line. So whatever I am writing, whatever I am giving you, just please go through it properly. If you are reading these notes completely, no need to read NCRT also. I am telling you. This benzoic acid, basically crystalline solid are further classified. Just I am writing, just note it down. We will discuss this in detail. Just note it down here. It is called as a molecular solid. This is called as a molecular solid. This is called as a molecular solid. Okay. This is called as an ionic solid. This is called as a covalent solid, a network solid. This is called as a metallic solid. Right? Now let us see the example, similarly example for amorphous. Okay. So for amorphous solid, we have examples like first is quartz, glass. Then we have a rubber, plastic. Okay. Glass, as I told, given you the example also glass. So these are the examples of amorphous solid. Just remember all the examples. Okay. These are very important for you. Otherwise, if you forget any one of the example and suppose in exam they will ask you, they will simply give you the names and ask you which type of solid it is. So for that you have to remember them. Then only you can answer. And there is a very beautiful line in the NCRT which is mentioned here, and it has been asked also. So you just remember this line. Is it possible to convert the amorphous solid into the crystalline solid? Is it possible? Can we convert a amorphous solid to a crystalline solid? Can we convert amorphous solid to a crystalline solid? Is it possible? I'm asking a one question. Is it possible to convert an amorphous solid to a crystalline solid? I say at least yes, no, something you should say. Everyone is sleeping, or like you are listening to the class? At least say yes or no, something you should say.
Sir, I don't know, sir.
Okay, you don't know. See, we can convert when we heat the amorphous, like amorphous solid when heated. If we heat the amorphous solid and cold it down immediately, means you take the amorphous solid and you heat it, okay, at some particular temperature. When you cold it down, it will directly convert it into the crystalline solid. So how, what we have to do, we have to take the amorphous solid and we have to heat it, okay, at a particular temperature. It will become a crystalline solid. So when amorphous solid, this is a very important question, amorphous solid when heated above a certain temperature converted to crystalline solid. Okay, it will convert into a crystalline solid. That is a very important thing. Okay, so this is a very important line. Just remember, if we have a if we have a if we have a like amorphous solid, and if we heat it at a temperature, okay, and at a particular temperature, this amorphous solid will automatically convert it into a crystalline solid. Okay, any doubt? Any doubt is there?
No, sir.
No,
Oh,
sir.
okay, so just note it down and please let me know if you're completed. Completed?
Yes, sir.
Yes,
Okay.
sir.
Okay, good. So next we are going to, as we have discussed now, there are the two types of solids are there, crystalline and amorphous. So first what we have discussed, first we have discussed solid, liquid, gas, then we discussed the properties of solid, then we discussed the type of solid, and now we have come to the next thing which is important for us is the crystalline solid. Obviously the amorphous solid is not important for us. We are not going to see any further detail in amorphous. We will discuss about the crystalline solid. So let us discuss about the crystalline solid. Okay, so we will start with the crystalline solid, and first our first thing will be, what are the types? Okay, types of crystalline solid, like how many types of crystalline solid we have. Okay, so just give me 1 minute. Let me just make a table in your copy so that it will be easier for you to remember. Okay, this is a table which is given in NCERT. Okay, and if the question come in your exam, 3 times the questions has been asked from this table only. Okay, 3 times in the NEET they have asked this question, even in the JE also. this question from this table only. So this table is very important, very important. Okay. See, if you are preparing for AIR, good AIR under 100, then everything is NCRT is very important for you. Okay. So let us discuss the thing. The first is, in this table we will talk about the type, which type of crystalline solid. Second is the particles. What is a constituent particle? Then we will have a force. We will talk about the force. And then we will discuss about some examples. We will talk about the physical nature, like in physically how it exists. Then electrical conductivity. And I am giving you guarantee, if you remember this table, you can solve all the questions. Whatever the question will be asked, it will ask from this table only. Because I have covered everything. Okay. See, first type of crystalline solid we will have is called as a molecular solid. Okay. First is molecular solid. It is called as a molecular solid. First type of solid is molecular solid. What is a constituent particle? So it is a molecular solid. So its constituent particle will be molecule. It will be made up of molecule, obviously. What type of forces you can see in the molecule? In molecule, what type of force is present? What type of force is present in molecule? It is called as a IDP, IDP. IDP, IDP. What do you mean by IDP, IDP? What do you mean by IDP, IDP? IDP means IDP. IDP is, just write in your notes. IDP means induced dipole interaction. IDP means induced dipole interaction. IDP means induced dipole interaction. So in this, the molecules have a induced dipole interaction. Okay, induced dipole interaction. In this, examples are like, for example, here those type of like examples will come where the dipole moment is 0. In this case, dipole moment. Do you know about dipole moment? What is dipole moment? Do you know about dipole moment? Okay, no problem. If you don't know, we will discuss that also. But for now, remember that those molecules in chemical bonding, I will tell you how to find the dipole moment. In just remember that examples are those molecules whose dipole moment are 0. For example, CCl4. Okay, CO2. Okay, and inert gases also come under this, like H2, I2. These are the molecules, right? So they will have a example of this. Now, as it is a weak force, so it will be soft. Electrical conductivity, it is a good conductor of electricity or a bad conductor of electricity, just by common sense. Is CO2 is a good conductor of electricity? Is CO2 is a good conductor of electricity? Is CO2 is a good conductor of electricity? Whatever the examples I have mentioned here, is they are the good conductor of electricity? Can H2 conduct electricity? Say yes or no. Hydrogen atom can conduct, hydrogen gas can conduct electricity.
No, sir.
Then it is an insulator, simple. Insulator. What will be the melting point? It's very high or weak? It's like low. Is the melting point is very high? Just see example. You will able to answer everything. If you remember the example, you can tell everything. CO2 melting point is very high or low? Or you can see that induced dipole interaction, IDP. This is a very weak force. So obviously the melting point will be very low because the force is very weak, right? So the melting point is low, very low melting point. Simple. Are you getting the point? This
Yes,
is
sir.
the first example. Second, we have called as a ionic solid. Second type of solid is Let me give some space. Okay, yeah. Second is called as a ionic solid. Second type of solid is ionic solid. Ionic solid means, or let me give just we will write it letter. First we will write polar solid. Polar. Okay, first we will write polar solid. Basically, or you can better say that it is a, like, it is a classification of these two. One minute. Basically, ionic molecular solid will consist of polar, non-polar, and hydrogen bonding, H bonding. Basically, it's come under the molecular only. This is the classification. This is the classification of molecular solid: polar, non-polar, and H bonding. So in all the cases, the constituent particle will be molecule only, right? Second, the type of interaction will be like, what are the type of interaction? It will be in polar. In basically in polar, we type, which type of interaction we will have? We will have DP. DP means dipole interaction. This will have a dipole. Okay, this will have a dipole interaction. DP means dipole interaction in this case. Clear? H bonding, you know, hydrogen bonding, we have a H bonding is there. That is also a type of a dipole interaction. Okay, in H bonding. In polar, we will have a like 1 minute. Sorry, I have written, this thing should be above. Okay, this is dipole, DP, and this is called as a London forces. Here we have a London forces. Okay, this is the London forces. I have a lack of space. 1 minute. Just a minute. Okay. Yes. Now the example of polar, for example, polar molecule examples you can give, like for example HCl. You can give like HCl. Okay. This is the example of polar molecule. You can give the example of SO2. London forces, you can give the example of um, like AR, CCl4 that we have written above also. And here you can give the example of hydrogen bonding like H2O, right? H2O is the example of hydrogen bonding. Ice. These are the examples you can give. Okay. Now, next thing is like what type of force will be there. So if you talk about the force, it will be soft, and this is hard, right? This is hard. And like if you talk about the conductivity, obviously no will one have a conductivity, all are insulator. If you talk about the that like what type of point, so this is like very low, this is low, and this is relatively little high is there, but you can consider it as low only. It is not that much differences there. So this is basically the classification of molecular solid. We have classified the molecular solid into the, basically this is about the molecular solid, and that molecular solid are classified into the different types: polar, non-polar, and H bonding. And these are the example, these are the forces in this, and like what is the physical state, what is the electrical conductivity, what is the melting point. There is a one exception is also there, we will see in the letter what are the exceptions are there. Just note this slide. This slide is very important. We have seen the only one classification, we have to see the some other classifications are also there. Is it clear to everyone? See, it is look like quite theory, but I am telling you, just if you when we cover this theory in today's session, na, from tomorrow it's all mathematical only. Okay. See, the thing is that who want a good rank, they have to study everything. They can't leave this part. They have to study this also. Okay. So it's a little theory, I understand. But if you cover this theory properly, now I'm very sure that 2-3 marks are fixed for you. Okay. 2-3 questions you can directly tick and just go. You no need to even solve also. Okay. So completed?
Yes, sir.
Okay.
Yes, sir.
Okay. Now just we will move to the another classification. Just give me 1 second. Okay, yeah. So again, we will write here, we will have a type, then we will have a constituent particle. Okay, then we will have a force. What type of force is this? Then we will have a example. Then we will have a physical nature. Then we will have a electrical conductivity. And the last we will have a melting point. So our next is called as a ionic solid. Ionic solid. See, ionic solid means ionic compound. Ionic compound will have a what? It will have a ions, right? It will have ions. Ions means we will have a cation. Cation mean positive, and we will have a anion, that is negative, right? So that is the ions will have. Force will be what type of force? If it is a charge are there, so that means it will have a which type of force? Electrostatics, right? That we are studying also. So electrostatic force. Example, any ionic compound you can write like KNO3. Okay, that we have seen also. Like MgO, CaCO2, Cl2. Okay. Physical nature will be what? It will be hard. We know ionic compounds are hard and brittle. Electrical, it has a ions, but it don't have a free electrons. Okay, it don't have a free electrons, so it is insulator. It is an insulator because it has no free electron. For conductivity, you need a free electron, right? But it don't have a free electron, so it is an insulator. But remember, this is an insulator in only solid state. In water, it will conduct electricity. That we will discuss in the chemical bond. Like in chemical, when we go through the chapter like chemical bond, then we will study about that how the any compound conduct electricity. Okay, so insulator in solid, but conductor in liquid, in water, because it goes under a hydration. Okay. Second is melting point. As the force is like as the force is strong and it is hard, so it will have a high melting point also, right? Clear? This is about the ionic solid. Similarly, we have another type of solid that is called as a covalent solid. After this, covalent solid, which is also called as a network solid. Okay, which is also called as a network solid. This is also called as a network solid. What do you meaning of this covalent solid or network solid? First thing, the constituent particles are the atoms. It will have a atoms. Second, the force is going to be a covalent bond. It will have a covalent bond. How the covalent bond is formed? Covalent bond is formed by how? By sharing of electron. There will be the sharing of electron, right? Then the covalent bond will be formed. If you are not clear with this all things, no problem. When we read the chapter chemical bonding, then we will cover each and everything. Basically, chemical bonding is called as the heart of the chemistry, because after this only the student going to understand a lot of things. Okay, for example, SiO2 quartz. Okay, then we will have a SiC. Then we have a Al, aluminum nitride. Then we have a C, that is diamond. Okay, then we will have a C, that is graphite. These all are called as a like covalent solid. Okay, they are basically hard. They are hard except one. This is soft. This is soft. This is an exception. Okay, this is an exception. All are hard except this. Obviously there is no free electron, so it is an insulator. It is also an insulator. But remember, this is a conductor. Exception. Conductor. We will write the exception in together also. And if you talk about the melting point, then it is very high, because very big structure, so very high is the melting point is there, right? Now the next type of solid, that is called as a metallic solid. This is a metallic solid. What is the metallic solid means? There will be metals. Metallic solid means there will be metals will be there. There is a positive ions. We will have a, you can write ions, but it is positive ions present in sea of electron. Present in sea of electrons. Clear? So what type of interaction it will be? It will have a metallic bond. It will have a metallic bond. Example you can take, right? Example you can take, sorry, like copper, zinc, okay, iron. These are the examples of metallic bond. This is hard, but we know metals are malleable. Malleable means we can break it down into the thin sheet. Okay, and ductile. Malleable and ductile. Second thing, it is a conductor in solid and molten state. Both the state it conduct. And if temperature increases, my conductivity is going to decrease. Okay, if temperature increase, this is called conductivity, which is going to decrease. And obviously this thing is going to be high, right? Because it has a strong force. So these are the different types of crystalline solids we have. Okay, I hope like you have to remember this whole table. Okay, if you want to solve all the questions, then this table and this table you have to remember. Basically we have first seen the molecular solid. In this there are the three classifications are there. Okay, then we have a ionic solid, covalent solid, metallic solid, in which the covalent solid has the strongest, and it is a like strongest one of the case, and there are the some exceptions are there. We will also note down the exception. Till now just go through this and tell me if any doubt is there regarding this what we have covered till now. If anyone have a doubt regarding whatever we have covered till now, please let me know, then we will proceed further. Until here you have to confirm me that you don't have any doubt, then we will proceed further. And we will solve some questions also. Any doubt is there?
No, sir.
Is it clear? There are a lot of theory is there, but yeah, you have to like go through all these things. Okay, so basically there are some exceptions from where the lot of questions are asked. So let me write down the exceptions for you. This all are given in NCRT. Now you go and just read the NCRT and try to match your NCRT with the notes. You will find that it is exactly same. Okay. Exception. The first exception is that, like we have seen, like graphite, it is a covalent solid, right? But it is a others are covalent solid or insulator, but you can see the graphite is a conductor, it can conduct electricity. Okay, so exception is that good thermal and electrical conductor, both electrical conductor. And second, we have a diamond. What about the diamond? Diamond is a, if you talk about diamond, then diamond is a good thermal but not a electrical conductor. Why? It is not an exception, you can say, but there is a reason for this. If you are interested, I am tell you the reason. They are good. They are basically why they are the good thermal conductors. They both are the good thermal conductors, right? Question is why? Because they have big structure. They have giant structure. Giant means big. Giant structures. That is why they are called as a good thermal conductor. Why it is a good electrical conductor? Because of free electrons. Because it has a free electrons. Whereas here, if you will see, there is no free electrons. No free electrons. So that way it is not a good. It is not a good electric. It is not a good electrical conductor, right? Second thing you can remember, that is melting point. Melting point we have seen. First is covalent solid. Okay. Then we will have a ionic solid, right? Then we will have a molecular solid. Sorry. Molecular So this is a variation of melting point. You have to remember. So this is the important thing, and this is a complete theory which is present in the first portion of a solid state, where most of the students are afraid of, because going through all this theory is very difficult. So you can see we have started with let me go through all things. First we have started with the type of solids. Sorry, first we have started that what are the different state of matter. We have seen the solid, liquid, gas. There are the three types of state of matters are there. Then we have classified this state on the basis of intermolecular force and intermolecular distance. This is the classification we have given. Then we move toward the what is the properties of the solid, or what is the characteristic of a solid. So these are the important characteristics of the solid which is given in the NCRT also. Then after that we have discussed about the types of solids, that is crystalline solid and amorphous solid, and we have seen the different properties of a crystalline and amorphous solid. After that we have seen this, we have went for the examples which are present in the NCRT regarding the crystalline and the amorphous solid, and then we have seen also that a crystalline solid, amorphous solid can be converted into a crystalline solid if 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 we heat it at a particular temperature, then at that point it will convert it into a crystalline solid. Then after that, going through this, we have went through the type of crystalline solid. We have first seen that first is molecular solid. In molecular solid there are the different classifications are there. Then after that, we have went for the ionic solid, covalent solid, metallic solid, and we have seen the different examples in the different classification. And the last we have seen that what is the exceptions. There is an important exceptions, that is two exceptions are there. We have also gone through this, and we also know the reason that why it is like this, and we have seen the variation of a melting point. Till here, if anyone have a doubt, please let me know. Is there is any doubt regarding anything? Is there is any doubt regarding anything?
No, sir.
Okay, just note it down. If you complete it, please let me know. We will do some like questions. Okay, then you will become more confident on this. We will do some more questions, some questions. Everyone is completed.
Yes, sir.
Please, everyone, let me know that only one person is saying. Other, what about others? Others are also completed, right?
Yes, sir.
Okay. So see, this is our first theory part of our solid state. Now the theory part is finished. Okay. There is no more theories there. Now we will move to the numerical portion, and that we will do tomorrow. Before going to that, whatever we have covered today, we will do some problems so that you will become comfortable to that. Just go through the whatever you have, whatever we have covered. Just go through the notes for 1 minute. I am writing the question, then we will solve. Okay. I'm writing the questions for you. We will discuss this. Question. So that you will get a practice of whatever we have covered today. Completed? Everyone? Everyone completed?
No, sir.
Okay, okay, completed. After completed, after completing, everyone unmute your mics. I will not repeat.
Okay, sir.
Everyone unmute your mics. Do it fast and unmute your mics. Unmute yourself. Everyone unmute yourself. I am not asked to only one person. Fast. Ashwin. Kartike.
Yes, sir.
Yes, this. Okay. Sharvana. Saravana. You also unmute yourself. Saravana. Are you there or you went? I think. Are you there? Saravana, are you there or you went? Please unmute yourself. I think he is not there. He just went. Okay. Yeah, Ashwin, you can unmute yourself. Why, Ashwin?
Yes, sir.
Yeah, everyone has unmuted. Okay, so now we are going to solve this question. Okay, you have to tell me which type of solid it is, whether it is a molecular, metallic, ionic. Okay, so first P4O10, which type of solid it is? Just use your logic. See, on what basis you can tell the answer? If you try to see the constituent particles, okay? Just see the constituent in this ions, atoms, positive ions, and molecules. So if you use this concept, so just come to this question. P4O10. P4O10 is what? It is what? Is it ion? Is it a ion? P4 is it ion? Sorry? Sorry? What are you
No.
saying? First tell me, is it a ion? P4O10 is a ion? Obviously
No.
not. There is no positive charges there. It is not a ion. Is it a metal? P418 is a metal? No. It is not a metal.
Molecule.
Yeah, it is a molecule. So it will be what type of solid? It is
Molecular solid.
yeah, it is a molecular solid. Very good. Now second, graphite. Graphite come under with which type of thing?
Covalent.
Ionic solid.
Not ionic solid. This is a covalent.
Covalent.
We have seen its example also. See, graphite, covalent solid, or you can say network solid. So it is a covalent solid. Now SiC, which type of solid?
Covalent solid.
Covalent.
Covalent solid. Yes,
Covalent solid.
very good. Covalent solid. RB. Which type of solid? RB. Rubidium. Which type of solid? First thing, is it a molecule? Is it a molecule? No, it is not a molecule. Obviously, molecule means we have more than two atoms will be there, right? Then only it is a molecule. It
Sir,
is not
atom.
atom. Okay, atom is this. So what type of solid it will be? It has an atom. Then what type of solid it will be?
Covalent.
No, it's not a covalent solid. Covalent means it should form a covalent compound. Na? There is no covalent compound is there.
Ionic solid.
Ionic, there is no ionic charge is there. Na? Is it a metal? Rubidium is a metal. If you remember, it is a metal. S block element. S block elements are metals. Okay. So it is a metal. So it is a metallic solid. Simple. If it is a metal, it is a metallic solid. Clear? I2. I2 is what? I2 is a, it is a molecule. It is a molecule. See here. Non-polar molecules. You can write it here I2 also, H2 also. This all are non-polar and they are molecules. So it is a molecular solid. Okay. I2 is a molecule. So it is a molecular solid. P4 is what? P4 is what? What is P4?
Molecule.
Yeah, molecular solid, right? What about plastic? What about plastic? Now it is a good question. What about plastic? Is it a,
Amorphous solid.
yeah,
It is amorphous solid.
it is a amorphous solid, right? Amorphous solid. Very good. Silica. What type of solid it is?
Covalent solid.
Yeah, covalent solid. Covalent solid. Brass. Brass is what? What type of solid? Brass is what? It is a, is it a, it is a brass is what? Brass, it is a metal. If you remember, brass, it is a alloy of zinc and manganese. So it is a metal. It is a metal. So it is a metallic solid. Okay, it is a, anywhere you see metal, it will be always a metallic solid. If it is a metal, it will be a metallic solid. What is this? This is what type of solid? NH43PO4, ammonium phosphate. What type of solid it is? Ammonium phosphate. What type of
Molecular
solid?
solid.
No, it's not a molecular. If you see, it will break into ions. See, NH4 plus PO4 minus 3. You can break it into ions. So it is an ionic solid. It is an ionic compound. Okay. It is an ionic compound. So it is an ionic solid. Similarly, ammonia. What type of solid it is? Ammonia. Ammonia is what? What type?
Molecule.
Yeah, it's a molecular solid. It's a molecular solid. What about urea?
Molecular solid.
Yeah. Yeah, molecular solid. Water?
Molecular. Molecular
Molecular
solid.
solid. Dry ice? Molecular solid. We have seen dry ice. We have seen the example. Ice, dry ice. All dry ice means nothing. It is CO2 only. Dry ice is CO2 only. It's nothing. It's a molecular solid only. It's a non-polar molecule. CO2. Array, I have written here. CO2, non-polar. Okay. So I hope now you are confident to find out which type of solid it is. So generally in the exam, they will give you as such type of compound, and they will sometimes they ask you also to tell me which type of solid it is. So if you have remember all this example, and if you have a concept what I've told you, you can solve now any question on this topic which we have covered now. Most probably like our this solid state will go for 4 to 5 lectures it will take to cover the solid state, and we will finish the solid state and you will enjoy it. I hope you have understand everything. Like, do you have any doubt regarding anything? Is my, like, you have any suggestion for me?
No, sir.
No, sir.
Is it okay for you?
Yes, sir.
Sir.
Have you enjoyed the lecture?
Yes, sir.
Any,
Yes, sir.
Yes,
any
sir.
doubt?
No.
Sir.
Okay, no problem. Then we will meet in the morning. Okay, and we will go just solve the homework problem which I have given in physics. Okay, then we will discuss those problems. Okay,
Okay, sir.
okay, bye.